Hello, Assalamualaikum. In today's video, my team and I is going to present how to solve questions related to arithmetic and geometric topics. These are the content that we will present in this video. The filler table for part A and B, as well as the solution for part A and B. Now let's look at the filler table first, which will presented by my friends.
So for my part, I will be presenting the filler table for part 1, which is about Jane's monthly savings plan. So let's break it down step by step. So what is filler? Filler stands for facts, ideas, learning issues, and actions. So for this case, first is the fact. Jane starts by saving $100 in the first month. Secondly, every month she increases her savings by $30. And lastly, her goal is to save enough money to buy a car. Next is the ideas. The ideas is to calculate how much she will save in the 12th month. We will use the arithmetic sequence formula. Next is to find her total savings of the 12 months. We will use the sum formula for an arithmetic sequence. And finally, to determine how many months she needs to save at least $2,500, we will solve an inequality. For the learning issues, we need to understand how to use the arithmetic sequence formula to calculate specific terms like the 12th month. Secondly, we also need to learn how to compute the sum of an arithmetic sequence to find the total savings. And lastly, we will need to solve inequalities to figure out when she reaches her saving goals. And finally, the action steps. First, we calculate her savings in the 12 months. Then, we compute the total savings for 12 months. And lastly, solve the inequality to find how many months it takes to save at least $2,500. So, by following these steps, we will have a clear understanding of Jane's saving plans and when she will meet her goal.
Okay, next I'll be explaining the filler table part B case 1. So now let's start with the facts. The initial solution concentration is 1000 ppm. Each dilution reduces the concentration by 20%, meaning that each term in the sequence becomes 80% of the previous one. This forms a geometric sequence where the common ratio is 0.8. Okay, next let's explore the ideas. We can use the formula for the nth term of a geometric sequence to find the concentration at any step. The sum formula for the infinite geometric sequence can help us determine the total concentration removed after a specific number of dilutions. Finally, the sum formula for an infinite geometric sequence allow us to compute the theoretical limit of the concentration after infinite dilutions. Now, what are the learning challenges we need to address? First, we need to understand how to calculate the terms and sums of a geometric sequence. Second, we must learn how to subtract cumulative concentration from the initial value to find the removed amounts. Lastly, we should interpret the infinite sum in a practical real-world content. Finally, the action steps to solve these problems are to calculate the concentration after 5th dilutions using the nth term formula. Determine the total concentration removed after 10 dilutions by applying the sum formula for an infinite geometric sequence. And lastly, compute the theoretical concentration limit after infinite dilution using the infinite sum formula. So, in conclusion, by following these steps, we can effectively analyze the geometric sequence formed by the dilutions and solve for the required concentrations. This approach not only applies to the specific problem but also equips us with tools to handle similar situations involving geometric progression in real-world contexts. Thank you.
Let's look at how to solve part A, which is arithmetic question. We all know that arithmetic are 3 types of formula that we commonly use in every question. So the yellow highlight is the formula that we will be used in this question, while the blue highlight shows that the meaning of the formulas. such as A1 is the first term, N is the rank of the term, Sn is the summation of the n term, and others. Let's look at the question. Jane starts a saving plan by saving $100 in the first month and decides to increase her saving by $30 each subsequent month so that she can save for a car. We know that the question states that she saved $100 in the first month and then she adds $30 each month. This means that for the second month, she saved 100 plus 30, which is $130. So this pattern will be continued until the 12th month. Question A. If she continued to increase her monthly savings by $30 each month, how much will she save in the 12th month? So the question asks how much for the amount of the 12th month. So we are going to use this formula, which is AN equal to A1 plus A minus D times D. We all know that A1 is 100 and D, which is the common difference, is 30 because A2 minus A1. N is going to be 12 because we want to find the 12th month. Now that we have all the information, we can substitute it into the formula and find the amount for the 12th month, which is $430. Next, question B. What will be the total amount of the money she will save by the end of the 12th month? The keyword here is the total amount at the end of the 12th month, which means the question asking for the summation of money at the end of the 12th month. So we are going to use the summation formula to solve this question. So we already know the value for A1, N, which is 12, and then we're substituting this value into the formula so we can find the summation for 12th month, which is 3,180. For the last question C, if her goal is to save at least $2,500, how many months will it take her to reach this goal? So the question given the value for summation of N, which is 2,500, N is the value that we need to find, which is how many months. So we can put all the information into the summation formula because we already know that A1 is 100, D is 30. So here we got the quadratic equation. So to solve the quadratic equation, we use the quadratic formula. Why don't I use the factorizers? Because maybe a little bit hard to get the same value for the equation. After putting all the value into the quadratic formula, and we got N is equal to 10, which is around 10 months, then we'll reach for her goal.
So we move on to the part B, which is geometric progression. So the yellow highlight is the formula, the blue one is meaning of the formula. A1 is for first term, R is the common ratio, Sn is the sum of term position, An is the number of term, N is the term position. So the question is, a chemical engineer start with the solution concentration of 1000 ppm part per million and dilutes it by 20% each time, reducing the concentration for testing. So in this question that I booked is start, which means the A1 solution is 1000 and dilute it by 20% each time is the R. So the question is, what will be the concentration after the fifth dilution? So we know that our R is not the 20% because that is for dilutes. So what we have to do is we find the concentration first. 100 we must minus with the 20%, so we got 80% or 0.8 for the concentration. So we put it on the formula, the value that we know, we put it on the formula, which is an equals to a1 multiplied with r and minus 1. So we got the answer. The next question is, what is the total concentration removed by the end of the 10 dilution? So the question wants us to find the sum of the concentration. So formula that we use is Sn equals to A multiplied with 1 minus Rn over 1 minus R. Why we use this formula? Because the R is less than 1. So we insert the value that we got into the formula. So we got the answer is 4463.13. Last but not least is, after an infinite number of dilution, what concentration will the solution approach theoretically? So the question wants us to find about sum of infinity, which is the formula for this is sum infinity equals to A over 1 minus R. So we insert the value that we know, like A equals to 1000, R equals to 0.8. So we got the answer is 5000. That will be all from us. Thank you for watching.